In honor of Manufacturing Day, I'm going to present a project here that we have developed at the Canada France Hawaii Telescope. And it's just one of many projects that we do here that we have the capability to do in-house. This is the Astrometric Camera. It attaches to our telescope and moves with it. Some of our instruments, we have 5 instruments here. 2 of them are what we call narrow field of view instruments. They have guiders that keep the telescope pointed at the right location on the sky. However, sometimes it's difficult to find the right target in this huge sky. So the camera here consists of some off-the-shelf parts. We have the optical tube assembly. We have a Crayford focuser. And we have a camera here, and we have a back focus adapter. The camera here, these 3 components, camera, focuser, and OTA, are all bought off the shelf. However, to get the stiffness requirements that we need as we're moving around the sky, we had to design a custom mount for it. Everything was designed in SolidWorks, analyzed, FEA analysis in SolidWorks, thermal analysis of the camera itself as a whole unit was analyzed in SolidWorks, and all the machining, all the aluminum you see here was machined in-house. What you don't see here is the camera stand that makes this whole assembly you see to the telescope, which had stringent requirements as well. Together, this and the camera, or this and the stand, deflects under, moving side to side, deflects by 20 arc seconds. Here is the Astrometric Camera stand that bolts the mount that you just saw to the telescope, and you can see it's kind of a peculiar design. We have this bottom plate and the top plate that are separated by these carbon fiber tubes, 1.5 inches inside diameter, and we have the ball joints that connect the tubes together. The design was carefully done so that under different thermal loads throughout the year, the stresses are minimized. And one of the requirements of this Astrometric camera stand is that it has to support the camera cantilevered over and outside, so that its field of view is outside of what we call the top ring on the telescope.
Many of the things we make here at Canada France start off as solid blocks of aluminum like this. Sometimes aluminum, sometimes steel, stainless steel, titanium, we don't know what it is. Depends on the material properties necessary for the product. But this semi-sphere joint was made out of a solid block of aluminum like this. And when the CNC machine gets done cutting the part, we end up with a beautifully finished, tight tolerance part that will serve its need perfectly. So here we can see the rods for this space frame mount that are either under tension or compression and create an incredibly rigid structure. They're built out of carbon fiber tubing, very light, very stiff, thermally stable, and then they also have these ends that will be bonded into the carbon fiber tubing with a very, very specific kind of epoxy used in aerospace industry. And there will be micro beads in there that will maintain a consistent clearance between the aluminum and the carbon fiber. Okay, so we're going to go ahead and finish up the last set of operations to build this top plate. I've got it all loaded up in Mastercam. I've assigned all the tool paths and defined all the tools and sizing. All that's left to do is put the plate back in the machine and locate it properly and push go, and it'll make the part for us. Alright, so we've got to put the material in the machine. Okay, so I've got the part in the machine. I've squared it using this indicator, sweeping up and down the sides and across the back to determine that it's square in the machine. And then I have to define a center point for the XY axis. So what I've done is I've used a previously drilled and tapped hole. I've got a tap in there that fits very, very good. And I'm just swinging my indicator around the tap until the indicator reads 0 all the way around. And that will establish our X and Y 0. So now that I've found 0, using that little tap and sweeping around it, I've manually entered this little G code right here that's going to turn X and Y into 0. And when I run that, just like a program, you'll see the command position X and Y go to 0. And once it comes time to save the program, just to give you an idea of how old this machine is, it looks new. We've taken good care of it, but this machine's pretty old. So when it comes time to save it, it's going on a floppy disk. Since the tools were already loaded in the machine and all the tool heights calculated, all that's left to do once the program is loaded in is push start. Okay, we've got all the pockets cut. Now we're going to go ahead and drill the holes in the isogrid, the last 3 remaining, and the holes in the pockets. Do some tapping. Feeds in one direction and feeds out at twice the speed in the opposite direction. That's how it's done. Okay, and there's the finished part out of the machine, washed up. You can see the little ball socket in place, and basically the rods will go in the holes and up to the upper plate. and all the rods will be either in tension or compression. It's an extremely rigid way to build a mount. Space frame is what it's called. And that was just a quick look at what Canada-France-Hawaii telescope does that aligns with National Manufacturing Day.